Solving systems is a lot of work, especially when there's 3 equations with 3 unknowns. So I have it all here, but I'm going to explain how I got everything so you know what's going on. So with the 3 systems, I looked at the 3 equations and I saw that this bottom equation here only had 2 variables, and that was the key to doing this problem. So what I did right here is I decided to solve that. You could solve that last equation for any variable, y or x, but if I tried y, I'd get a fraction, so I went ahead and solved it for x. And when I did that, I got negative 3y minus 5. So then what you want to do with that is you want to plug that into the other top 2 equations. And that's what I did right here in this part. So the first equation, the x right here, got replaced with negative 3 minus 5. In the bottom equation here, I replaced that x with the same thing. And then what I did down below is I just showed you the simplification. So the top equation, I just simplified it down to negative 2y plus 2z equals 7. The bottom equation, I simplified down to negative 8y plus 14z equals 21. Okay, so that's good because now we only have 2 variables. And now we can solve it like a regular solving a system. And I'm going to do it with elimination. So I put them together, as you can see right here. And then I tried to match the z's. Could you match the y's? Absolutely, you could. You could have just multiplied the top one by negative 4 and the y's would match. I just chose the z's. So I multiplied the top by negative 7, and that's what I got right here. And then I added them like you always do with elimination. That got rid of the z's, solved it off, and got y equals negative 14/3. Okay, so now we know what y is. So now I was going to plug it back into, you could plug it back into either of these right here. Because you want to choose those because they only have 2 variables. Don't go back to the original because you don't know what x is yet. So I chose to plug it into the negative 2y plus 2z equals 7. And when I did that, and then coming up here, I'm showing the substitution. Of course, you can do this on your calculator, but I just showed you the getting the fractions and solving z for negative 7/6. Okay, then to get the x, you could take the x and the z, you could take the y and the z, you could plug it back into the one of the more complicated ones, but I thought, why not use the shorter one that I'd already solved up here for x being negative 3y minus 5. So I just plugged in the y value of negative 14/3 there, and that is how I got x was 9. So that's all 3 of them. That's solved now. X is 9, y is negative 14/3, z is negative 7/3. Okay, so then you should check your answer, especially on these complicated ones. It's not that hard. So I just plugged in all 3 variables and all 3 equations just to see that they checked, and all 3 of them checked. And so if they hadn't checked, I would have gone back and redone my algebra. I probably, honestly, if they didn't check, I would the first thing I would check is see if I copied the problem right, because I have a tendency to write things wrong, and just a little negative sign or a number wrong could screw it all up. And then if it wasn't that, and it was still not checking, I would start over again. I probably would not waste my time trying to go through to see where my algebra error was. I just start fresh and see. Usually I can figure it out if I do that all 3 ways. As far as the graphing it, drawing the system, I would go to Desmos and put them in there because it is a 3-dimensional graph, and see how Desmos does with that. I hope that helped you. I hope that at least helped you figure out the variables. The trick is always get the equations so they only have 2 variables in each one, because then you can eliminate one of the variables and then work your way back up to get the other 2 variables. All right, good luck with this. If you want any tutoring help, look me up. I'd be happy to work with you on this. Good luck with this.